the causal inference framework is all about breaking down validity into these two buckets. So internal validity, some folks think of this as like cause and effect in an experiment where you have high levels of control and you eliminate confounding variables, you eliminate alternative explanations. But this can also just be thought of more broadly as verifying the claim or general finding from a specific study. It is study specific. And internal validity is only relevant to the specific study in question. When you're looking at multiple studies or broader trends, you're looking at a different question. You're looking at external validity, which is closer to what extent can you safely generalize the internally valid findings of specific studies to other groups? More specifically, from the sample being studied to the target population, so going from your sample to your population, as well as moving from your population to other populations that you didn't initially intend to study. And these can both generalize across time and space, and broadly just questions of do these results generalize to other human beings. So for internal validity, these differ drastically by the kind of study. For experiments, these tend to be about making sure you have random assignment in that your groups are actually evenly distributed, because under random assignment, on average, your groups will be equivalent, but in any given study, they might not be. And so you have to do repeated assessments to make sure that your inferences are valid. For quasi-experimental designs, what we do in this approach is eliminate plausible alternative explanations. And that primarily focuses on controlling for covariates or creating plausible controls. And for observational studies, this is just trying to have good representative samples, because there's not much you can really do with observational studies beyond that from making a causal inference standpoint. And yes, for the observational folks in the room, I know I am overstating how useless observational studies are. I'm a quasi-experimental gal. I like the happy medium. But the general idea across all these different ideas with internal validity is that your finding is real, that the conclusion you've drawn from your study is real, is valid, is not caused by some spurious third variable. It's actually true. And within internal validity, you need good, valid, reliable measures. And so from this framework, it is implicit that you have valid and reliable measures to capture your associations or make your predictions, because you can have the best designed study, but if you have unreliable measures or invalid measures, it doesn't matter what you do after that. Garbage in to your measurement, and it just ruins your study. Garbage out. So measurement, incredibly important, and it's like a necessary but not sufficient condition to have an internally valid study. So it's like the foundation. Everything in causal inference depends on good measurement. So in external validity, I think I just spoiled and scooped myself in the last slide. But really, it's so just like internal validity is predicated upon having valid and reliable measures, external validity is predicated upon having internally valid studies, which are in turn based on valid and reliable measures. And here it boils down to, do the claims that you see in your study that are true in your study, do they hold up in other people's studies? Can you generalize beyond your sample to a population? So in general, for generalizability, think about it like the burden of proof. In psychological studies, My recommendations are to avoid simple generalizations to members of other cultures and people in different times and places and just general differences. And so here's what I've heard from many people. So those who question the generalizability of the study should propose how and why it's not generalizable. Personally, I really do not like that little caveat on how many people approach generalizability. I think that the burden of proof should be on the study itself. I personally believe that we should not assume that a study will generalize, because often that is an implicit assumption. So I take the approach that it's up to the authors to convince me, the reader, that the study does generalize beyond their sample. Often, I am not convinced, but my approach is not the norm, and I encourage you to think critically about the samples used and what types of broad claims are made about generalizability. You'll notice in many of the criticisms I've had about old tests, which I don't think you've seen yet. You will see this soon. Some of my criticisms of old tests are that their samples, their reference groups, are all white middle-class kids from New Jersey. And then they magically generalize to everyone. Why New Jersey? Because that's where Education Testing Services is. It's either New Jersey, Princeton, New Jersey area, or if you were working with Pearson, I believe that is in Iowa. Two very homogeneous areas. So reference groups are a really key thing to connect with this causal inference approach. Okay, so given that we are in deep tobacco country, I want to talk about my basic, slightly less arbitrary rules of thumb for thinking about generalizability and giving us an example of the British doctor study and how this kind of works. So my quick rule of thumb is if you could have participated in the study, then the results most likely generalize to you. So if you're the kind of person who will answer surveys, will participate in psych subject pool instead of writing the super burdensome essay, then most psychology studies and most political science studies will apply to you. My more thoughtful rule of thumb is if the reasons you could not have participated are unrelated to the findings of the study, then the results probably generalize to you. Again, this is all conditioned upon having an internally valid study with very well-established measures. And also, this approach can be applied to groups other than you, but I find it helpful to kind of think about it from a me approach, just to get you started, but you can kind of swap out for anybody. Okay, so the British doctors study. So, does smoking cause cancer? Well, this question may now be really obvious that it does. However, this was not obvious or well established in the medical community before this British study, which started in about 1951. So, doctors were actually often really associated with tobacco ads and would endorse them to almost a comical degree. If you've ever watched Mad Men, you'll kind of get a sense of what that transitional period was like back before the British doctor study was well kind of empirically demonstrated, and its rapid proliferation of scientific evidence. So Dahl and Hill published results in 1954 and 1956, and they tracked 40,000 plus male British doctors. This is about 2/3 of all registered UK physicians in October of 1951. So they examined whether there was a relationship between smoking and cancer. They compared non-smokers, former smokers and current smokers by age. And frankly, this entire study changed the conversation about cancer and smoking. So let me illustrate. So here we are comparing fatality rates. We look at the first figure in the blue line. We have non-smokers, so male doctors who never smoked. And we can see that their mortality rates did not meaningfully differ from those who stopped smoking before the age of 34 versus those who were still smoking at every given age. So you can see there's a big gap in likelihood of survival. If we look at that 50% point, so only 50% of smokers live to the age of 70 versus 50% of non-smokers or former smokers live to the age of 83. That's how you can kind of read this table. Just grab that 50% mark, eyeball it, and see the differences. And the later and later you stopped smoking, the wider and wider the gap between non-smokers and former smokers becomes. It's not a lot of daylight up until age 45. However, even if you stopped smoking by your mid-50s, the damage was done. Your likelihood of survival drops compared to non-smokers. Even if you've quit and stopping smoking at 65, still, not a lot of time to make up the difference. Now, eventually, everybody's dead, so at the end, it doesn't matter. If your goal is to see who lives to be 100 or not, then whether you smoked or not doesn't make a difference. But if you want a better chance at making it to like 90, don't smoke. Because it'll kill you faster. So let's apply those slightly less than arbitrary rules of thumb. Could I, Mason Garrison, have participated in the study? No. Why? Okay, well, I've listed the reasons here. 1, I'm not British. 2, I'm not a man. 3, while I'm a doctor, I'm not an MD. And 4, I was born nearly 40 years after this study started. So, are any of those reasons, though, related to the study's findings? No. Does my reason for not being British relate to smoking or lung health? No. I didn't get to pick where I was born, didn't get to pick to have an SRY gene, did not want to be an MD, so maybe that one, but my reasons for wanting to not be an MD is I'm not really interested in medicine. I like teaching about statistics. Also, born after the study was published. So, yeah, again, but none of those have anything to do with the relationship being studied. So, can this study probably generalize to me, even though I don't meet any of the criteria? Yeah. This is one where you just don't smoke. I realize that seems obvious now, but at the time it was revolutionary. And feel free to hit me up during office hours if you want to know about the hot statistical mess that was causal inference in smoking in the 50s. Oh, there were some fiery debates that were really fierce and petty. Because technically you can't ethically randomly assign people to smoke, so there's no way to make a causal inference. But realistically, don't smoke. It'll kill you faster. So if you are interested in learning more about smoking statistics, causation, or the history, please check out some of these slides or shoot me an email and I'm happy to chat with you. Okay, so that wraps up our causal inference perspective. So I'll see you later.